Hi everyone and welcome to this video on matrices. I'm not going to go too much into the real basics of it. If you want to go back over those things like the order of a matrix, meaning the dimensions of it, or the conditions that we have to be able to multiply matrices, or even the process for multiplying matrices, I would suggest that you go back and have a look at the year 11 matrices videos. I'm just going to kind of jump into these. They should still be fairly straightforward, so hopefully you find that to be the case. So the first one, we have matrices A with the elements 3, 0, -5 and -2, and B with the elements 1, -1, 3 and 4. So we need to evaluate A plus B. To begin with, I'm just going to write them down. 3, 0, -5, -2 plus the matrix B, which is 1, -1, 3 and 4. And it's very logical, this process, so I hope it's not too surprising that we'll end up with 4 and -1 and -2 and 2, right? Because we just add the corresponding elements of the matrices. To do 4A, well, that just means 4 times the matrix A, which again was 3, 0, -5 and -2. So again, hopefully not too surprising, you end up with 12, 0, -20 and -8. 2A take 3B. Rightio. Slightly more complicated, so 2 times the matrix A minus 3 times the matrix B, and we evaluate. So multiplying first, it's going to give 6, 0, -10, -4 minus 3, -3, 9 and 12. And then adding the corresponding elements. 6 minus 3 is going to be 3. 0 minus -3 is also going to be 3. -10 minus 9 is -19. -4 minus 12 is -16. And we're done. KB, so this is just some constant multiplied by the matrix B, which was 1, -1, 3 and 4. So multiplying each thing there by K, we get K, -K, 3K and 4K, and we're done. Slightly more complicated, the matrix multiplication. So I need to do the matrix A multiplied by the matrix B. So that is 3, 0, -5, -2 multiplied by 1, -1, 3, 4. You might remember this process. We go across the first matrix and down the second one. So I need to multiply the things to get the result in the first row and first column of this matrix. And to get that, I multiply the first row with the first column. So I'm going to do 3 times 1 plus 0 times 3, working across the first row and down the first column. I'm now going to do the first row with the second column. So that's going to be 3 times -1 plus 0 times 4. Now I'm on to the second row. So I'm going to do the second row with the first column. So that's -5 by 1 plus -2 by 3. And then the second row with the second column. So -5 by -1 plus -2 by 4. And now I can just evaluate this. So I'm going to end up with 3 in the first one. I'm going to end up with -3. I'm going to have -5 minus 6, so that's going to be -11. And I'm going to have 5 minus 8, which is -3 as well. So there we have it. IB. Now you might remember that I is a special matrix. It's called the identity matrix, and it just has ones on the leading diagonal. So going from that top left-hand corner to that bottom right-hand corner. Everything else should be zeros. Matrix B was 1, -1, 3 and 4. And so I'll multiply these again, going across the first one, down the second one. So that gives 1 times 1 plus 0 times 3. First row with the second column is going to give 1 times -1 plus 0 times 4. Second row with the first column is going to give 0 times 1 plus 1 times 3. And second row with second column is going to give 0 by -1 plus 1 by 4. And evaluating that should just give 1, -1, 3, and 4, which you might recognize as just B. And this is one of the nice properties of multiplying by the identity matrix. It doesn't actually change anything. And the last one, if 4a minus x equals 3b, find x. So, I know that 4 times the matrix A, which was, what, 3, 0, -5, -2, minus some matrix x, which also has to be a 2 by 2 matrix, because that's what happens if we can add them or subtract them, and that equals 3 times the matrix B, which was 1, -1, 3, and 4. Just check that I got that right. 3, 0, -5, -2, nice. Okay. I'm going to evaluate this first one, so that's going to make 12, 0, -20, -8, minus some matrix x equals, that's going to make 3, -3, 9, and 12. And I'm just going to rearrange the equation. I'm going to add x to both sides. I'm going to subtract the matrix from the right hand side of the equation. So x should equal 12, 0, -20, -8 minus 3, -3, 9, and 12. And now I can evaluate that. So 12 take away 3 is 9, 0 take away -3 is 3, -20 take away 9 is -29, and -8 take away 12 is -20. And there we have it. Anyway, I think that's about all for this video, so I will see you next time.